Okay, so our next speaker is Yuki from, I hope I say this right, Fukuoka, yes, in Japan. And it is his first time in the United States. Isn't that exciting? Yeah! Okay, so he's already had the very authentic New York experience of being robbed. So, yeah, I know. So you need to be extra nice to him, obviously, right? And show him, other authentic New York experiences, like being on a Broadway stage and getting tons of applause, right? Yuki loves Journey and also Queen so much that his coworkers have nicknamed him Freddie. I think that's adorable. But he's going to be talking not about Queen, but about the Swift compiler, and specifically about how Swift literals are treated. So this apparently will help us understand how the Swift compiler works. And I don't know about you, but I'm super excited to know how the Swift compiler works. Yeah? Awesome! Give it up for Yuki!
Hey, hello everyone. In this talk, you will learn deep side of Swift literal. Please enjoy. Hi, I'm Yuki from Japan. Please call me Freddy. Oh, sorry. Oops. And I'm an iOS engineer at LINE Fukuoka, located in the south part of Japan. And I'm in charge of the local Swift community called Hakata.Swift in Japan. Okay? Okay. Okay, so these are the topics what I will talk. We will deep dive into literals by following from high-level topics like the usual Swift code to low-level topics, code topics such as the compiler phase. In the first place, how do you understand the meaning of literal in computer programming? Okay, I listed some definition of literal from two sources. For example, Wikipedia says that literal is notation for representing a fixed value in source code. Let's look into the usual Swift code. As you can see, 42 is assigned to constant value, but we can use 42 without defining any complicated structure. It can also be said on string in the last code. So in this talk, I want to define literal as a linear way to represent the actual data for programmer. Literal looks very simple things, but it has deep connection with deep side of Swift. Next, I'd like to tell you why I want to talk about deeper side of Swift literal today. Actually, we have many chances to learn about Swift more than other languages. For example, Swift is an open source project from Apple. We can see the Swift compiler code in GitHub every time. As you know, we can make a proposal new Swift feature with our hand. But I don't think it is so easy to learn Swift deeply. Why? As you can see, most of the Swift compiler code is written by C++, so there are so many complicated code at first. Yes. So now I chose topic Swift literal to describe deeper side of Swift. But why do I want to talk about Swift literal? Because I'm one of the engineers who learned Swift compiler from Swift literal. You will see the deep side of Swift through understanding the deep side of literal. And after listening to this talk, why don't you start learning compiler further than ever and contribute Swift to make our Swift better? Okay? Now, please enjoy the Swift literal. First, I'll recap about Swift literal. From the top, there are integer, float, string, and Boolean literal. As you know, integer and float literal represent numeric things, and the string literal is for sentence, and the Boolean literal is for representing flag. Okay, next let's recap the literals with the nested type. From the top, nil, array, and dictionary literal. To use these literals, context of nested type is necessary. Otherwise, compiler complains with error. For example, wrapped type is necessary as using nil literal, and element type is necessary as using array literal. Finally, I'll introduce some special literals such as color, image, and file reference literals for resources. These literals represent resources which is often used in applications. And these literals are rendered as actual data in Xcode, and it is editable by a natural way like picking resources. Let's look at the color literal as example. In Xcode, color literal is rendered as actual color, and we can edit color by using color picker or adjusting color code. And same as color literal, actual image is rendered on the image literal. And we can edit by image picker. Some Swift literal features are friendly for humans. This topic will recap what literal is in computer programming and literals in Swift, and special literals which are supported special feature unlike usual literal. Next topic, let's look into what literal is from object of literals. From this topic, I'll talk about the literal with deep side of Swift, like a compiler flow and a low-level intermediate language. However, please enjoy deeper side of Swift. First, I'll focus on the type of value which assign literals. This is maybe recap for you. As you know, there are two ways to determine the type of assigned literals. One is type annotation. The other one is type inference with information about default type of literal. Here is an example code of type annotation. As you can see, there is type annotation after colon. In this code, 42 will be determined as int type. And if you want to use the integer literal as float type, just declare the float. In this code, 42 will be assigned as a float type. Next, let's move on to type inference way by using default type of literal. As you know, we don't have to use type annotation every time since each literal has default type. In this code, 42 will be assigned as int since default type of integer literal is int. However, image and color literal have several default types, and it is depends on what library is imported. For example, if you import AppKit, image literal will be converted to NS image, but it will be converted to UI image if you import UI kit. You saw how literal type is determined, but there is one more thing better to know. Some literals are treated as an object which cannot be used on our usual Swift code on compiling time. Before I explain about it, I'd like to talk about about compiling flow of Swift. Swift code will be compiled step by step with converting to some materials in the order of abstract syntax tree, Swift intermediate language code, and LLVM IR code and binary file. Generally, we are calling the flow after SIL as Swift intermediate language as backend. Also, we are calling the flow before Swift intermediate language as front end. I focus on the Swift intermediate language code. From now, I call it as SIL. Swift code will be converted the SIL code in Swift compiler from type-checked abstract syntax tree, and some of optimization are operated on SIL code. Next, I'll introduce SIL code format a little because we will read SIL from next page. I displayed easy example of SIL format, SIL code. The left value starts from % means value declaration, and object is assigned to value at each line. But value cannot be reassigned object to value like last line code. However, you may think, why do we need to watch SIL when deep diving into literals? Because I think this is a good way to watch how Swift code is treated by compiler. Also, as I said, reading compiler code is not easy for us at first, so reading SIL is easier way to understand how compiler works than reading compiler code directly. Okay, let's start focusing how literal is treated by Swift compiler. Here's a code which is assigning the integer literal to constant. And this is a part of SIL code related on integer literal and int value from above Swift code. Let's focus on the SIL code. The first line code is allocation of constant value and assigned to %3. So %3 means allocated place on memory. The second line is value declaration code, and value type is built-in.int64 with number 42. What is it? In fact, at first, some literals such as integer, float, are treated as an object which name of type starts with built-in dot. And this object will be used when generating actual Swift type. From now, I will call this object as literal object because converted from literal. Please remember, literal object is an unofficial name and limited in this presentation. So please be careful when using this name. These are the example of list how literal will be converted. For example, float literal is converted to built-in.fpi e364, and string literal is converted to some information such as pointer and length of data. And some literals can be converted different literal object from default. If type is annotated or casted, and the literal can be converted to specified type. You may find some number after built-in.int. This means the size of object. For example, 1 bit is enough to represent the Boolean value, so literal object for Boolean is treated as built-in.int1. However, special literals such as color and image have no literal objects. They are directly treated as initializer specified by the imported library. Now, we know this is an object converted from literal. And as you can see, literal object has exactly number which is specified by Swift code. After generating the literal object, this object is passed into initializer. What is it doing? Currently, it is okay to understand that some Swift type which can be generated from literals has special initializer which receives the literal object. And initializer of default type for literal is called if you don't annotate any type. Now, we can recognize that this code is generating actual Swift type from literal object. Finally, int object will be assigned to allocated place on memory. Good job for reading SIL. Additionally, let's focus on the Swift code which is using string literal. String literal will be converted to SIL code like displayed. It looks so complicated, but we can read it easily. Let's focus on the first block of code. This code consists of literal object from string literal. String literal treated as several objects such as pointer of sentence, len of string data, and a flag which indicates the string is ASCII or not. Some people may think this flow is very similar with using string in C language using malloc function. After generating literal object, this literal object will be passed to string initializer. Finally, as you can see, string has initializer which receives literal objects. This is the same as another object like int and float. In this topic, we learned many things, so I made a conclusion of this topic. Swift literal are treated as literal object at first, and this object is used for initializer of actual Swift type. But we don't know why this literal object is passed to Swift type initializer and how it is used. In final topic, I'll describe these mysteries. This is the final topic. I'd like to introduce architecture of type converted from literals. As I explained, some literals are treated as literal objects at compiling time. For example, integer will be treated as int64. This literal object will be passed to initializer of actual Swift type. In fact, this initializer implementation is required if the type conforms with a protocol. This protocol's name starts with expressed by between. You may think, what are these protocols? The type conforming with expressed by between literal is compatible by literal object. This is a definition of expressed by integer literal, expressed by between integer literal. As you can see, initializer should be implemented which receives the literal object. And this initializer is called when assigning literal by equal. Int is conforming this type, so this initializer will be called when assigning integer literal by equal. You may know similar protocol which name starts with expressed by. Please note that there is no between in this protocol name, unlike expressed by between literal protocol. This protocol makes conforming type compatible from literal by using equal. Firstly, let's recap how to conform with this protocol to make our type compatible by integer literal. At first, please set alias to associate type name integer literal type. The type should be compatible from integer literal. Next, please implement initializer which receives the value which type is integer literal type. At last, you can use your type with using equal and literal. CG float is also using expressed by float literal protocol for converting from float literal. And inside the variable type depends on the CPU architecture which using. By the way, I said that we have to set integer literal type at first. This associate type has a rule. In fact, this associate type should conform with expressed by between literal protocol. I'll show you what this means by showing flow of converting literal. This is a flow of converting literals. As I said, literal will be converted to literal object and it will be actual Swift type. I detailed Swift type block. First, literal object will be passed to type which conforming with expressed by between literal protocol, such as int, float, and string. As you know, these types are predefined by Swift. And if needed, these types will be converted to type which conforming with expressed by literal protocol, such as CG float. But please remember that we cannot use expressed by between literal protocols in our usual Swift code. These protocols are supported their future by only low-level side of Swift compiler. This is the last topic of this session. I think we haven't known yet about what literal object is. As I said, literal is treated as literal object at compiling, and it will be passed to initializer of Swift type. But do you know where passed literal object will go? In fact, this literal object will be stored as variable. But how is it used? Oh, sorry. Oh. How is it used? For example, literal objects are used in arithmetic operators. Sorry. Please wait. Will go? Sorry. In fact, this literal object will be stored as variable. But how is it used? For example, literal objects are used in arithmetic operators. Here is an example of comparison operator on SwiftInt. At first, literal objects are referenced from left value and right value on expression. Next, these literal objects are passed to backend function. It looks literal object is modified by backend function. Because literal object is an expression that backend object as front-end object. Literal object is a value we want to use the most and manipulate as data, like modifying by for arithmetic operators, evaluation by comparison operators, and using as data. And Swift type from literal are wrapping this object. Oh, sorry. Finally, result is returned from the function as backend object, so it will be converted to Swift object. Sorry. I will show you this converting flow again. We follow this flow with protocols, and we can convert them to architecture of Swift type. This is a picture about the architecture of type from literals. Some Swift types like int, float, and string are wrapping literal objects in innermost of structure, and they are also wrapped by some types such as float. When calling some operator to modify value, each layer operation function is called in order from the deeper. Backend function will be called in the end of modify backend value. Let's proceed to conclusion of this topic. Sometimes generated from literals such as int, float are wrappers of literal object. Int and uint are wrapping same literal object because there is no unsigned object in backend of Swift. Signed and unsigned backend functions are called separately at Swift side. And we learn literal object is a backend object. Literal object is a value we most want to use and manipulate as data. And Swift types from literal are wrapping this object. I think we learned huge things in this session, so let's recap from first. This topic, we recapped what literal is in computer programming and many literals in Swift, like integer and array. And special literals, which are supported special feature, unlike usual literal. Some literals are treated as literal object at compiling time. For example, integer will be treated as between.int64. This literal object will be passed to initializer of actual Swift type. Some Swift type like int and string are wrapping literal object in innermost of structure, and they are also wrapped by some types such as float. And backend function will be called when modifying data. In the end, I'd like to share some materials with you. I believe Apple Swift repository is the best materials. I said they are complicated code, but they also have many documents which help your understanding. Please check it if you are interested in. I introduced SIL in this session, but SIL has already been talked in Try Swift Tokyo and helps you to understand more. Please check it on YouTube. I'll share URL with my presentation. One more thing, and there is a big news. A conference focused on Swift compiler will be held on 19th November in Japan called Swift C Kaigi. Please attend if you want to learn Swift compiler, and why don't you meet a geek of Swift? That brings me to the end of my session. Did you enjoy? So, okay. If you have any question and opinion, please ask me freely. Let's start learning deeper side of Swift with us. Thank you for listening to my session.